Hey everyone, welcome to our next video. In this video we're going to be talking about variables and expressions. Alright, so let's start off by talking about what are objects and what are variables. So an object is the way that Python or the interpreter stores a value in memory. Okay, so it's used to represent a value. A variable is a name that we give to a value so that we can use it later on. So let's take a look at an illustration of creating an object. I'm actually going to look at the interactive one here. So starting off, step one, let's say we say print 2 plus 2. Well, what is Python going to do with this? The first thing it's going to do is it's going to look inside these parentheses and say I need to figure out what this is before I can print it. So it's going to go ahead and do an arithmetic add. 2 plus 2 is 4. And we can see it stored that 4 over here in memory location 96. So memory can be thought of kind of like mailboxes on a street, and each mailbox represents a house, so there's a number that corresponds to it. 96 just happens to hold this 4. Okay, so at this point, it then goes ahead and it passes that 4 to the print function, which actually prints it out like we saw here. And then at that point, it's no longer needed. Excuse me. Nothing's referencing it anymore. So the interpreter is going to come around and it's going to see that and it's going to do something called garbage collecting, or it's going to go ahead and delete that value out of memory. Alright, so here we're creating a variable, x equals 7. So x can be used as a placeholder to represent this value 7. That 7 has to be stored somewhere. So we can see that the interpreter chose to put this at memory location 98. We can see the value here. And then over here we just have this x that represents 98 for us. So really, what a variable is it allows us not to have to memorize memory locations. Instead, we can just remember something like X or a word that we use to represent that variable. It's kind of synonymous with DNS on the internet. So DNS is the reason why we can type in google.com instead of the IP address for google.com. Okay, so once we're ready to retrieve it, print X. In order to print X, Python's going to have to go and look in memory and look up X. So it'll look up X and see, okay, well, X is memory location 98. So you want me to print this value that's stored here. And that's what ultimately gets printed out here. Alright, so assignments. And we basically talked about assignments last week. There's not a whole lot to learn here, but let's go ahead and formally discuss it real quick. So assignments are a way to assign a value to a variable. The assignment operator is the equal sign. So we can see that up here in this illustration. Ignore the semicolon. We don't want to use semicolons in Python. This is actually from c4learn.com, so this is probably for the C language or maybe Java. But we use this equal sign, and sort of the abstract definition of it is our variable name equals some sort of an expression. And that expression is evaluated, or I'm sorry, the assignment operator is evaluated from right to left. Okay, so what does that mean? That means that if we have something on the right hand side like 20 times 2, that 20 times 2 is going to take place and be simplified down to 40 before that value is actually stored in the variable. One thing to keep in mind is that values can change. So if we set value equal to 20 here and then print it out, later on we could reset value to something like 10 and print that out and see that value doesn't that value actually changed. Alright, so let's look at an example of this. Age equals 2 on line 3. So that is a very simple assignment operation. We're just assigning the 2 to age. Same thing here, just a little bit more complex. We got an expression on this side, so we know that we need to do this multiplication, age times 7, before we store it in dog age. So what Python's going to do is it's going to look and see, alright, well, where is age stored in memory? And what value is stored there, and it's going to find that the 2 is stored there currently, and that 2 will replace this age, so we'll have 2 times 7, which will ultimately get multiplied for 14, and then the 14 will be stored into dog age. Okay, and that's what we see down here. 2 in dog years equals 14. Next, we go ahead and update what age is. So age equals 3 now. So now what's stored in memory at that memory location, the value has changed. Instead of 2, it's 3 now. And if we print this out, we see that 3 in dog years equals, well, dog age is still 14. And we know that that's the wrong dog age, so we can see that down here. What we need to do is go through and update what dog age is now. So dog age equals age times 7. What is age? Well, the most recent thing that age was assigned to is 3. So 3 times 7 is 21. Store that into dog age, and then let's do our print one more time. Also, while we're looking at this, I want to point out one other thing about the print function, in that in order to print out variables, we need to not put that variable inside quotes, be it single or double quotes. So notice when I wanted to print out the contents of age, I just put age, and it's not in any quotes. We can also see that the syntax highlighting has not changed it to yellow. So yellow indicates a string literal in this particular text editor that I'm using. The commas separate variables from literals and other variables. Okay, so this is one technique that we can use when we're printing. We say age, print out the value of that, literally print out these characters right here, and then print out the value of dog age. Now something else that I want to point out, and it's very good to have or at least develop a good attention to detail when it comes to programming. And one thing you might notice is that there is a space in between the age 2 and this in dog years equals. In fact, there's also a space after this equals and before the dog age of 14. So whenever you separate your variables and your literals and other variables with commas, just realize that that comma is going to implicitly put a space into your printout. Okay. Alright, so a little bit more about objects here. Each object has the following. It has a value, a type, and an identifier. The value, as you can assume, is whatever it is that we're storing in that object. So it could be 20 if we're dealing with an integer, ABC if we're dealing with a string, 25.2 if we're dealing with a float. It also has a type. Okay, so we just listed the types for these. So the type is going to be int, str for string, or float, or it could be any other type as well. There's several other types that we'll learn about. And then lastly, there's an identifier, and a unique identifier that describes the object. And what this typically is the memory location that the object is stored at in memory. Okay, so this is going to be unique for each object in memory. So let's look at an example of this. In the Python interactive shell, I got name equals Bob. If I want to see the value associated with this variable name in the interactive shell, I can just type in that variable and press enter. And what that's going to return to me is the value. So we can see Bob is stored there. Then if I'm curious about the type, I might just pass the name variable to the type function. And this will let me know that the class is string. Lastly, I can also check the ID, the identifier, that memory location, by passing the name variable to the ID function. And we can see that that gives me back the location that the name was stored at in memory. Now we don't have to do that in the interactive prompt. We could write a script that'll print this stuff out for us if we were interested. So in this case, age equals 2. If we want to print out the value, notice I'm doing that technique again of a string literal, comma, age. So it prints out this literal string here, age is value, colon. The comma gives me an implicit space, and then the age prints out the value, so 2. Okay, so we can follow that same pattern. Age is type, type of age, class int. Okay, that makes sense because this is a whole number. And then age is ID. We'll use the ID function to find the identifier used for the age variable, and we see that that's right here. Hey, so one other cool thing, notice that we can put functions in here, and these functions like type and ID will be evaluated to find out what the result of it is before it is passed to the print. Alright, so variable naming. Sometimes we call these identifiers. You'll see that term used synonymously throughout the book and throughout other programming material that you might find online or other textbooks. So what rules do we need to follow? What makes a valid variable name in Python? Well, it needs to be a sequence of letters. So A through Z lowercase, A through Z uppercase, and actually the underscore is also valid. Additionally, digits are valid, so 0 through 9. Anything else would not be considered a valid letter in a Python variable. So we can't have colons in there, we can't have periods and commas, the ampersand, dollar sign, carets, things like that. Those are not valid variable names. They have other meanings in the Python language. Python is case sensitive. So if we create a variable called car, all lowercase, and we create another variable called car with an uppercase C, those don't equal each other. They're not the same thing, and they're going to reference two different values. Additionally, variables must start with a letter. So they need to start with one of these. Notice that an underscore does count as a letter. It can be followed by digits. So as long as the very first character of a variable name starts with a letter, the rest can be digits, or it can be a combination of letters and digits. Either one of those is fine. You also can't use reserved words. So we're going to learn about some of the reserved words as we're digging deeper into the language. But for now, realize that some things that we can't use are other identifiers, like the print function. We don't want to come up with a variable name called print because print already means something in Python. Alright, so in addition to these rules, there are some good conventions that we want to follow. So good variable names describe the purpose of a variable. I should be able to look at your variable and understand what's stored in it based upon the name of it. We also want to avoid starting a name with double underscores. Double underscores has conventional meaning in Python, so there's nothing functionally that you're going to mess up by creating a variable that starts that way. However, other programmers, when they look at that, they're going to be thinking about this conventional meaning, which we should learn more about that in CSCI 145. And then lastly is PEP 8, the Python Enhancement Proposal. So there's a lot of proposals out there for how to make Python better, and this is just a proposal on how to write code neatly and consistently. The idea here is that we'll use all lowercase and separate words with underscores. So let's look at an example. The number of students attending UCLA. If we want to create a variable for that, There's several that we could create. Following the PEP 8 standards, we would probably want to do something like this. A very descriptive name. It's multiple words, so we're separating it with underscores. Do keep in mind that white space, so the space character is not valid inside a variable name. So we can use underscores to sort of represent a space or to at least visually separate these words so that we can read them easily. Some less meaningful names, although not too bad, UCLA, NUM, NU. NU's not that great. NUM could be given the context, and UCLA is really not descriptive enough to let me know that I'm dealing with the number of students at UCLA. The size of a television set measured as its diagonal length. Well, again, we want to be very descriptive, so diagonal underscore TV underscore size underscore inches. That's probably the best variable name we could come up with for that, right? Size really isn't descriptive enough because what is this the size of? And SZTV, although that may make sense to us, and we realize given the context that SZ is size, another programmer may not realize that or may not get the full context of your problem. The word for the ratio of a circle's circumference or diameter. Pi is perfect for that. I mean, that's what pi is. We don't want to use single character variable names if we can help it. P is not descriptive at all. I have no idea what that means or what that stands for. Alright, and then lastly we have the number of jelly beans in a jar as guessed by a user. So num guessed jelly beans, user guessed jelly beans. Guess, I could see guess being acceptable in some cases, especially if your program is only guessing jelly beans, then it's pretty easy to figure out what the guess is. But num and njb, maybe not as descriptive. Alright, so here's just a screenshot of some reserved words, and we will learn about most of these as we go through the course, but these are all words that we cannot use to create a variable because they already have a meaning in the Python language. Okay, so additionally, look this over. I have valid variable names over here. Like I said, it has to start with a letter. Underscore is considered a letter. And we can have digits after that letter. So if we tried to start with a digit, that's going to be a problem. In fact, we can see that over here under the invalid variables. 1 car is not valid. 5 grades is not valid. Food, exclamation point, is not valid because of the exclamation point. And none of the characters in this variable name are valid to use. Alright, so try to commit that to memory. It's not too hard of rules to understand, and it'll help you create your variables sensibly and hopefully so that they will make sense to other programmers as they look at your code later on. Okay, let's talk about floating point data types. Last week we mentioned that floating point data types are any numeric value that's going to contain a fractional component. So a fractional component would be something after the decimal point. So some examples here can be negative values, negative 1.15, can be positive 3.14, 1/3 here, just 1 or 0.33 repeating. So here what we have is, we're already familiar with string literals. If we write a floating point value in the source code, then that's known as a floating point literal because we are literally typing that into the code. So on this side we have the variable. We know that this guy is the assignment operator, and then over here we have what it is that we want to assign, our float. So later on, if we take the type of pi, we'll see that it is actually a float object. There's a few different ways that we can represent floats. So we can do scientific notation, which is the same as doing a number times 10 to a certain power, and we just use this e to represent that. So num equals 2.3 times 10 to the second, and we can see that it equals this. Exponential notation is also possible. So if we just want to raise something to an exponent, we can use double asterisks. We've already seen that a single asterisk represents multiplication. So if we use 2, then Python knows that we're doing exponential notation. So 3.5 times or raised to the power of 2 equals 12.25. One thing that we want to be careful of is overflows. So there is a limit to the size of a number that we can represent in Python. So the largest floating point value that we can represent is 1.8 times 10 to the 308th power. You can see that right here on section 2.5 out of the Xi book. And the minimum floating point value we can represent is 2.3 times 10 to the negative 308th power. If we go outside of those bounds, so if we go lower than this or greater than that, we're going to get something called an overflow error. And that just means that the bits needed to store this particular value in memory are greater than the number of bits that we can use to represent that value. So we're essentially overflowing out of the size of bits that we have to represent the value. And we can see what happens. We end up getting one of those tracebacks like we saw last week, letting us know what line it happened on and then what type of error occurred. So just be cognizant of that. Normally we don't run into that issue, but if you're dealing with very small or very large numbers, that's something that you just want to keep in mind. Okay, so expressions. We've been throwing this word around, and I'm not sure that we've actually formally defined it yet. So an expression is a combination of variables, literals, and operators that evaluate to a value. It can just be a literal. Okay, so when we're looking at assignment statements, what's on the right-hand side here is going to always be an expression. In its most simplest form, it'll just be a literal, like 0. So the literal integer 0. In other cases, we may be doing addition and multiplication, or negating something, taking the negative value of longitude. As we're evaluating expressions, we want to remember what we learned in algebra. So PEMDAS, or please excuse my dear Aunt Sally. The order of operations are parentheses, exponents, multiplication, division, addition, subtraction. So arithmetic operators. We've seen some of these already. We've seen plus, minus, multiplication. We've even talked about exponentiation today. Let's talk about division, floor division, and modulo. Okay, so let's look at some of these ones that we're not as familiar with. Let's say we want to take a look at division. Division works as we would expect it to. Okay, division, if we say that a equals 3 divided by 4, what do you think is going to be stored in a? Well, it's going to be a floating point data type. We can verify that by using the type function and telling it we want to know the type of a. So we see that that's float. And if we want to see the value, we can just print that out. 0.75. Now, something that you may not be as familiar with is floor division, or floored division as they call it here. Floored division is sometimes called integer division. And so what we're dealing with is we're basically going to drop down to the next lowest integer if we're a floating point data type. Let's do that same example again and see the difference. So a equals 3, floor divide 4. So the floor division is just 2 division signs. And if we look at the type of A, we'll see that it's an integer now. So like I said, sometimes this is called integer division. And then from there, let's go ahead and print out the value and see what it is. Well, if it's an integer and we're going down to the next lowest integer, I would assume that this is going to be 0. And it is. Okay, so that's just something to keep in mind. If the value was 10.9999999, if we were to take the floor of that, it would become 10. So just keep that in mind. The next operator is the modulo operator, sometimes called the remainder operator. So as we're dividing two things, we get a remainder. So let's see what, if we do a equals 3 mod 4, so the modulo sign is a percent sign. If we modulo that, it's going to do 4 divided by 3, and it's going to let us know what the remainder is. So let's see what the remainder would be. First, let's look at the type, since we've been doing that. Modulo is going to always give us back an integer. Then let's look at the value. So the value is 3. So how many times does 4 go into 3? 0 times, right. So what would the remainder be? The remainder would be 3. Okay, let's look at it the other way. What if we say that a equals, 4 mod 3? Well, how many times does 3 go into 4? It goes 1 time. And if we take 3 away from 4, so that 1 time, what are we left with? We're left with 1. And that is the value that we get back from the modulo operator. So hopefully you can see how we calculate modulo, or the remainder. What's some of the usefulness of this? Well, if we want to count numbers and wrap around, we could use modulo for that, because if I say, well, let's say 4 mod 3, we just did that, that's 1. Now what if I do 5 mod 3? That's 15, because I didn't do mod. Okay, let's fix that. Let's do 5 mod 3, that's 2. And then 6 mod 3, it's 0, because 3 goes into 6 2 times, and we're left with nothing left over. Okay, and then the whole thing starts over again. So 7 mod 3 is 1, 8 mod 3 is 2, 9 mod 3 is 0. Notice that we won't ever get 3 as the result. In fact, the result is always going to be something from 0 up to, but not including what we're modding by. So 0, 1, 2. If we were modding by 4, then the possible values that we would get back would be 0, 1, 2, and 3. Another useful thing for modulo is just to let us know if we're dealing with an even number or an odd number. So if we take any number, let's say 11, and we mod it by 2, if we get a 1 back, we know that we're dealing with an odd number. But if we get a 0 back, like in the case of 10, we know that we're dealing with an even number. Okay, so again, it's following that same principle that our values that we get back are going to be from 0 up to, but not including, what we're modding by. So 0 and 1 are the only possible values we would get back here. And if we want to check and see if a number is even, like let's say that we prompted someone for their age, right? So age equals input, we'll prompt for an age, let's say 18. Now, first off, before we get too far here, what kind of data type is age? We want it to be an integer, But we need to keep in mind that anytime we call input, we're going to get a string back. So before we can actually use this, let's go ahead and convert it. So assignments are evaluated from right to left. It's going to convert it to an integer and then store it back in itself, or overwrite where it was saved. Okay, so from here, if I want to determine if that age that someone entered is even, I could just do age mod 2 and check what the return value is. So the return value here is 0. That indicates to me that age is an even number. So hopefully that makes sense. Play around with these arithmetic operators. Make sure you understand them so that you can use them in your programs. Okay, so parentheses are always evaluated first. Just keep that in mind. If you want to force something to happen before something else normally would with the order of operations, then you would just use parentheses. For example, if we wanted this addition to take place before the multiplication, then we would just put a parenthesis here, and of course we could just imagine that these guys aren't here. Okay, so this is an illustration of the order of operations just in a little bit more detail. Parentheses first, exponents, and then multiplication, division, and modulo are on the same level. So as we are evaluating an expression, we're looking at it from left to right. And if we come across a multiplication, division, or modulo, then we're going to go ahead and do that at this point in the order of operations. Same thing here with plus or minus. They're at the same precedence levels, so whichever one we come across first, we'll just do that. Alright, so wrapping up the chapter here, let's look at how text is stored in memory. We've already seen that strings are different than numeric data types like integers and floats. We can't use them for multiplication like we would when we convert something to an integer or a float. And that's one of the reasons why we've been having to change what our input is when we get it. So text is actually encoded using a specific standard called Unicode. So Unicode uses unique numbers to represent characters, and Unicode's actually pretty flexible. We can represent every character in the known world using Unicode, including hieroglyphics and other obscure dead languages that don't exist anymore. We call these things code points. So if we look here, you'll see that we have like our special characters first. The space is the same as the value 32. After all of this, we get into our uppercase characters, and the uppercase characters come before our lowercase characters as far as the code point is concerned. And this is really just for your knowledge as to how Python is storing the character in memory. There's ways that we can access these, or we can convert between the code point and the character itself, or we can convert the other way, and sometimes that can be useful if we're doing things like a Caesar cipher or some other sort of translation on the text values. Also important is escape sequences. So, excuse me, the escape character is the backslash. The backslash has a special meaning inside of strings. So let's say that we are, I guess the classic example here, we want to print out something that has a double quote in it, and we're using double quotes to denote our string literal. So typically what would happen is this would open our string literal, and this would close it, right? And then that would be it. But if we put a backslash in front of it, then Python says, oh, you know what, I know that you're not closing this string. What you really meant is for me to put this backslash, or I'm sorry, this double quote inside your string. So when we print it out, You can see another one right here, backslash double quote, and then this double quote actually closes the string literal, so it's associated with this one at the very front. So when we print it out, we get he said, hello friend, in double quotes. Okay, same thing for single quotes. If we're going to start something with a single quote, and if for some reason we need to put a single quote in it, then we can just escape it with a backslash. Now, with the backslash having a special meaning, that means if we want to actually print a backslash, we need to escape it too. Alright? So this is a good example of like a file path in Windows. We know that Windows uses these backslashes to separate directories. So if we need to actually print one, then we need to do a double backslash. And if you try to do just one and the character that follows it is not one of these special escape sequences, you're just going to get an error. Okay, so another important one is the new line character. The new line character is essentially like pressing the enter key. It takes us to the next line in the output. So if we formulate a string literal that looks like this, my name dot 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 backslash n, so this is the new line character, is John dot dot dot, the output is actually going to take up 2 lines. My name is John. So additionally, another character that you'll probably use is the backslash t. That's for a tab or an indent. So this can be really good for like creating tables or something like that. Bake cookies, backslash n, backslash t. So what is this doing? We're going to get a new line like we got here. That brings our cursor over here. The backslash t gives me a tab, and then I'm just going to print out the 1.1 preheat oven. So I'd mentioned back a second ago when we were talking about text that we can actually convert between the code point, so that number that represents the character, and the character itself. And that's what this function's for, the ord function, or stands for ordinal. So if we want to get the ordinal value of A, we can see that that's 65. And let's just go back and verify that. Let's look at this. And if we look for the code point 65, we'll see that there's an A there, capital A. We could go the other way if we wanted to. If we use the char function or chr, this function takes an ordinal value, okay, like 66, and gives us back the character, or the ASCII character in this case, although really it's Unicode. ASCII is another way of encoding text, and ASCII is actually the exact same in the beginning of Unicode. So essentially they're the same thing for us as far as the English language is concerned. ASCII characters use less bits to represent the character itself, so it's limited in the number of characters it can represent, which is why we use Unicode in Python. So if we go back and we look, we know that actually 66 is 1 after 65, and we also know that the code points were going A, B, C, D, so 66 has to be B. But if we're not sure, we can always go back and just double check that. Alright, so that wraps up the video for today. If you have any questions, definitely feel free to reach out to me. Jump into Slack and post in there if you want. If not, I'll see you guys in the next video. Thank you.